In the deepest voids of space, there are places where all the rules we know are broken, where gravity becomes a tyrant and reality itself bends to its will. We call them black holes. They are the ultimate cosmic mystery, silent and invisible, devouring everything that comes too close, including light itself. But what truly lies beyond that point of no return? What secrets are hidden inside the darkest objects in the universe? The truth is, no one knows for certain. But where knowledge ends, theory begins. Number 5, the singularity. This is the classical and perhaps most terrifying answer. At the heart of a black hole, according to Einstein's theory of general relativity, matter is crushed into a point of infinite density and zero volume. A singularity. It is a place where space and time cease to exist as we understand them. The laws of physics shatter. All the information of a star, a planet, or an unfortunate astronaut is compressed into an impossibly small, infinitely massive point. It's not a place, but a breakdown of the very fabric of the cosmos, a dead end for the universe. But is nature truly capable of such an absolute, or is this simply where our current understanding fails us? Number 4, the wormhole. What if a black hole isn't an end, but a beginning? The Einstein-Rosen bridge, more commonly known as a wormhole, proposes that a black hole could be one end of a tunnel through space-time. The other end? A white hole, a theoretical cosmic object that spews out matter and light, but which nothing can enter. Fall into a black hole in our galaxy, and you might emerge instantaneously from a white hole in another, or even in another universe entirely. However, the journey would be a violent one. Extreme tidal forces would stretch you into a thin strand of atoms. The bridge is also believed to be impossibly unstable, collapsing the moment anything tries to pass through. It remains a tantalizing but perhaps unreachable cosmic shortcut. Number 3, the holographic universe. One of the great paradoxes of black holes is what happens to the information of the things they swallow. Quantum mechanics insists that information can never be destroyed, yet a black hole seems to erase it forever. The holographic principle offers a strange solution. It suggests that all the information of the three-dimensional objects that fall into a black hole is unlost, but is encoded on the two-dimensional surface of its event horizon, like a cosmic hologram. Some physicists take this idea even further, proposing that our entire universe might be a holographic projection of information stored on a distant two-dimensional boundary. If this is true, then inside a black hole there is nothing. Just the scrambled two-dimensional data of everything it has ever consumed. Number 2, a baby universe. When a massive star collapses, it creates a black hole. But what if that collapse doesn't just end in a singularity? What if it rebounds? This theory, called cosmic inflation, suggests that the immense pressure and energy at the center of a black hole could trigger a new Big Bang. This event wouldn't explode back into our universe, but would instead create a new, separate bubble of space-time, expanding into its own dimension. Our own universe may have been born from a black hole in a parent universe. This cosmological natural selection means that every black hole could be a seed, a gateway to a new cosmos with its own laws of physics, forever inaccessible and invisible to us. Our universe could be just one branch on an infinite cosmic tree. Number 1, the fuzzball. Perhaps the most radical departure from classical physics comes from string theory. It does away with the singularity altogether. In this view, a black hole is not an empty void with a single point at its center, but a fuzzball, a tangled, messy ball of fundamental strings of energy. It has a defined surface and volume, just like any other object. The event horizon is not a sharp, one-way door, but a blurry, fuzzy boundary. According to this theory, when something falls into a black hole, its information is not destroyed, nor is it trapped on the surface. Instead, its constituent strings merge with the larger tangle, becoming part of the fuzzball itself. The black hole gets a little bigger, a little heavier, and the information is safely stored within its vibrating, chaotic core. The abyss, it turns out, might not be empty at all. It might just be full. From a point of infinite destruction to the birthplace of new realities, the contents of a black hole remain the ultimate unknown. These theories are not just intellectual exercises, they are attempts to reconcile the two pillars of modern physics, relativity and quantum mechanics. The answer, when we find it, will not only tell us what's inside a black hole, it will tell us what our universe is truly made of. The truth is not lost. It's merely waiting in the dark at the edge of understanding for us to finally see it. Thank you for watching.